Hey everyone, I'm Alejandro from Tutoring by Alejandro. I help students master SAT math with clear and simple explanations. If you find this video helpful, hit that subscribe button and check out my website, tutoringbyalejandro.net, where you can even book a free introductory tutoring call. Today we're going to cover the quadratic formula, quadratic equations. All right, so let's start with the basics. A quadratic equation is basically any equation that can be written in the form ax squared plus bx plus c equals 0. And here, what is a, b, where you see a, b, and c, those are just numbers or the coefficients, right? Okay, so the quadratic formula is what you see on the top, right? X equals negative b plus or minus the square root of b squared minus 4ac, and all of that divided by 2a. This formula will give us the solutions to the quadratic equation, also called the roots of the quadratic. Okay, so one thing to note, the part inside the square root, which I'll highlight here, right? This b squared minus 4ac, that is called the discriminant. It tells us what kind of solutions we're going to get. So if that value is positive, so if you evaluate b squared minus 4ac after plugging in the values, right? Just plug in this. If this value is positive, meaning greater than 0, then we will get 2 solutions, right? If this value is equal to 0, we will get 1 solution, okay? And if the value is negative, meaning less than 0, there are no real solutions, okay? And by solutions, you can imagine this as a graph, right? A quadratic equation models a quadratic function, which is sort of like a parabola, like a U-shaped. So if I have, let's say, my x and my y-axis, right? And let's say I plot an equation, a function of the form, let's say y is equal to ax squared plus bx plus c. I'm not going to give any specific numbers, but if I plot that, I'm going to get something like a U-shape, right? And every point that function touches the x-axis, that is a solution, okay? So in the graph I just drew, that would be our first case where the discriminant is greater than 0, right? Because there are 2 solutions. It's touching the x-axis in 2 points, right? If that graph would only touch in 1 point, right? So let's say if I have this green one, right, where it's just touching here, right at the top, that would be my single solution scenario, right? That means that discriminant in that case is equal to 0, okay? And lastly, if you have the case where there is no solution, it's going to look something like this, right? It's not touching the x-axis at all. So here there will be no solutions, okay? All right, great. So let's move on and try some easy examples, okay? All right, so this is our first example. We have x squared minus 5x plus 6 equals 0. So if you remember the structure of the quadratic formula, you can tell that a is equal to 1, right? Because that's what's accompanying the x squared. You have that b is equal to negative 5 because that's accompanying the x to the first power, right? And then c is equal to positive 6, right? So I know what is a, what is b, and what is c, and that's all I need to be able to plug into the quadratic formula. So let's do that. So I have x equals negative, right, from the formula. And now I plug in b, which is negative 5. So remember the parentheses here. Plus or minus square root of b squared, so that's going to be negative 5 squared, minus 4 times a, which is just 1, right? Times c, which is plus 6, right? Positive 6. All of that divided by 2 times a, which is 1, right? Okay, great. Let's keep going. Let me make this a little smaller. Okay. All right, so now we have a double negative here, right? We have a negative next to another negative. So this here becomes positive 5, okay? So let me get rid of that. And I'll rewrite it as positive 5. Great. Now we have the negative 5 squared. So if you recall the previous video, whenever you have a negative number raised to an even power, that's going to end up being positive. So 5 squared is positive, right? Same as negative 5 squared, right? Because it's being raised to an even power. So this is 25, positive 25. And then you have minus 4 times 1 times 6, which is 24, right? Just multiply all three together. Okay, great. And divided by 2 times 1 is just 2, right? Okay, great. Let's keep going. Now we have 25 minus 24 inside the square root. So that is just equal to 1. Okay. Okay, great. So now I have x is equal to 5 plus or minus the square root of 1, all of that divided by 2. So since the discriminant is greater than 0, I'm going to end up with two solutions. I'm going to end up with my, let's call it x1 and my x2. So my x1 is going to be the scenario where we take the positive, right? We take 5 plus the square root of 1 divided by 2, okay? And my other solution is where we take the negative. So that's 5 minus the square root of 1, all of that divided by 2, okay? So let's calculate x1. So the square root of 1 is just 1, right? So that's going to be 1. And then I have 5 plus 1 on the top, on the numerator, and that's just 6, right? Okay. Now I have 6 divided by 2, which is positive 3. Okay. So my first solution is positive 3. Okay. Now for the next solution, we have 5 minus the square root of 1. We already said that the square root of 1 is 1. Now I have 5 minus 1 in the numerator. So that evaluates to 4, right? Now I have 4 divided by 2, which is 2. Okay, so those are my two solutions. Great. Let's move on to the next one. Okay, so now we have 3x squared minus 12x plus 12 equals 0. Okay, in this case, we have that a is equal to 3, again, because it's accompanying the x squared. B is equal to negative 12 because it's with the x. And then we have C is equal to positive 12. Okay. So plugging that in will give us, again, you have minus, right, from the formula. And then you have B, which is negative 12. Again, negative and a negative right there. Plus or minus square root of B squared, which is negative 12 squared, minus 4 times A, which is 3, times C, which is 12, right? All of that divided by 2 times A, which is 3. Okay, great. Now, let's take a look at the discriminant. So you have negative 12 squared. Since it's a negative number raised to an even power, that's going to be positive, right? And 12 squared is 144, right? Okay, great. And now we have 144 minus 4 times 3 equals 12, right? And 12 times 12 equals 144, okay? So that means inside the square root, we have 144 minus 144, which equals 0. Okay? So since this equals 0, we run into the situation where there is only one solution, right? Because we're not adding or subtracting anything. 0, right? So I end up with x equals, again, you have a negative next to a negative, right? That means it's positive 12 divided by 2 times 3, 6, right? Okay, so I have x equals 12 divided by 6, and that comes out to x equals 2. In this case, there is only one solution, okay, because the discriminant evaluated to 0. Okay, great. Let's move on to the next one. Okay, so let's look at another example, this time with no real solutions. So here, a is equal to 3, right? B is equal to negative 2, and C is equal to 7. So if you recall the quadratic formula, hopefully you've memorized it by now. Here we go. Okay, let's evaluate the discriminant first. Okay, so the discriminant is b squared minus 4ac. That comes out to negative 2 squared minus 4 times 3 times 7. Okay. Negative 2 squared, again, it's a negative number raised to an even power. That evaluates to a positive 4 in this case, minus 4 times 3 is 12, and 12 times 7 is 84. Okay, so that means that our discriminant, after plugging in, right, comes out to negative 80, right? 4 minus 84 is negative 80. So I know I don't need to do this, just for further clarification, right? 2 times a, that was 6, right? 2 times 3, right? Okay, so since the discriminant is a negative number or less than 0, we can say that there are no real solutions, okay? So a lot of the time on the SAT, you're going to get an equation, and they're just going to ask you, how many solutions are there? So the way to answer that type of question is through evaluating the discriminant, right? So remember, if the discriminant is greater than 0, you have 2 solutions. If it's equal to 0, you have 1 solution. But if it's less than 0, like in this case, there are no real solutions, all right? Okay, moving on. All right, so let's look at this problem. How many real solutions does this quadratic equation, 2x squared plus 8x plus 8 equals 0, have? Okay, so this question isn't asking us to solve for x. It's asking how many real solutions there are. So again, this is where the discriminant comes in play, right? Remember, the discriminant is b squared minus 4 times a times c. And we said that if that value is positive, greater than 0, you have 2 real solutions. Okay. If it's equal to 0, you have just 1 solution. And if it's negative or less than 0, right, you have no real solutions. Okay. So let's calculate the discriminant for this equation. So we have a is equal to 2, right, because it's accompanying the x squared. B is equal to 8, because it's with the x. And then you have c is equal to 8. So plugging in to the discriminant, we have b squared is, in this case, 8 squared minus 4 times a, or 2, right, and times c, which is 8. Okay. 8 squared is 64 minus 4 times 2 is 8, and then 8 times 8 is 64. So that means that when I evaluate the discriminant, it comes out to 0. So since the discriminant equals 0, the quadratic has exactly 1 real solution. So in this case, the answer is 1. So that's the usefulness of the discriminant. It tells you the number of solutions without needing to solve the whole equation. So it's going to save you some time. All right. Okay, let's move on to the last exercise. All right, so now we have a word problem, which is the first one in this series. And don't worry, I'll be introducing more and more as I make more videos. I know a lot of students struggle with word problems, so let's get into it. So we have a ball is thrown upward from the ground, and its height in feet after t seconds is modeled by h of t is equal to negative 16t squared plus 32t. After how many seconds will the ball hit the ground again? Okay, so we're going to use the quadratic formula to solve this problem. I know we can use another method, but let's use the quadratic formula in this case. So, a quadratic equation is given by, it has the structure of ax squared plus bx plus c equal to 0, okay? And in this scenario, instead of x, we have t. So our t is going to be like our x, okay? And if you have a quadratic function, right, you usually use y as the dependent variable. In this case, we have h as our dependent variable. So because the value of h depends on the value of t, right? So think of the h as kind of like our y in the functions that you guys usually see, right? Now, the key word here is hit the ground. So that means that our height, h, is going to be equal to 0, right? That's going to be equal to 0. And plugging that in will give us negative 16t squared plus 32t, and then plus 0. And I'll show you guys in a second why I wrote that 0. Okay, so now I want to extract our values for A, B, and C for this scenario. Okay, so if you compare, we have that our A is negative 16, right? Our B is 32, positive 32, and our C is equal to 0. Okay? Because remember, our t is acting like our x in this case, okay? So just let me write those down. A is equal to negative 16, B is equal to positive 32, and C is equal to 0, okay? And in this case, we have that our quadratic formula is t instead of x, right, equals negative b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. Okay, so let's plug in the numbers. So we have negative 32 plus or minus square root of b squared. So that means I have 32 squared minus 4 times a times c. So our a is negative 16 and our c is 0, right? So this whole second term just evaluates to 0, okay? Divided by 2 times a, and our a is negative 16, right? Negative 16 times 2 is negative 32, right? So that's negative 32, okay? Simplifying a little bit more, inside the square root, we get 32 squared, which is 1024, okay? All of that divided by negative 32, okay, great. And if I use the calculator, like you guys will be able to use on the SAT exam, you will get that the square root of 1024 is 32, okay? So I end up with negative 32 plus or minus 32, all of that divided by negative 32. Okay, so since the discriminant was greater than 0, I'm going to end up with 2 solutions. So let's call them T1 and T2. Okay, so for the first case, I have negative 32 plus 32 divided by negative 32. Evaluating the numerator gives me 0 over negative 32, right? And 0 divided by any number is just 0. Okay, great. And then t squared, t2, our second solution, is negative 32 minus 32, all of that divided by negative 32. Okay, again, evaluating the numerator gives me negative 64 on the top, right? Divided by negative 32. I have a negative divided by a negative, so that means my answer is going to be positive. And then 64 divided by 32 is going to be equal to 2. So in terms of solving the quadratic formula, I have two solutions, t equals 0 and t equals 2. But we have to think with word problems in a practical sense, right? So even though we have two solutions, we have to note that t equals 0 was when the ball was first thrown. So this first solution, even though mathematically it makes sense, for our problem, it's not the solution. It's not the right solution. It's when the ball was first thrown, not when it hits the ground again. So our meaningful solution is t equals 2, which means that the ball hits the ground again after 2 seconds. Okay? So again, you could have done this exercise with factoring as well as some of the other ones, but I wanted to keep it to the quadratic formula. It's a very safe method of dealing with quadratic equations. So if you ever feel a little lost, as long as you know the quadratic formula, it's very easy to just plug in and solve for it, okay? It's a very safe way to either solve a problem from scratch or just confirm your answers, okay? So I really hope this video was helpful. If it was, please subscribe, please like, please share with your friends. If you need some extra help with tutoring, please check out my website, message me, and I offer introductory calls where we can go over your needs. And yeah, I'll see you guys in the next video. Thank you.